everybody, this is Bruce at Groxio Learning, and I've got the dog on the floor, and today we are going to work on our Tetris project. Specifically, we're going to do a little bit of geometry, but rather than get bogged down into trigonometry and things like that, instead we're going to play some geometric tricks to actually process some pretty sophisticated rotation. So this is how it's going to work.
Hey friends, Maggie here with Team Groxio. We are happy to have you joining us on our Tetris series. I'd like to invite you to come on over to Groxio, Grox.io, and you can sign up for our newsletter over there and see what other content we have available for you and get some information about signing up for some training with Bruce Tate himself. We'll see you.
So I've got this L shape, and I can use 3 basic operations to manipulate the shape through a couple of rotations. Here's how it's going to work. The first of the operations is a mirror. So if you can imagine a vertical line that's right down the middle, we're going to flip or mirror the shape, the L shape, from left to right. So it almost turns that L shape into the J shape. So this is called a mirror. And you can imagine that all we're going to do is we're going to leave the y coordinates alone, and we're going to subtract x from 5, and that's going to be our formula. So if we want to do a flip, it looks about like this. So we take the endpoints of that line that we're mirroring across, and we're going to swing that around. Instead of being vertical, we'll make it horizontal. And so we'll play the same game with the y-axis that we played with the x-axis before. So to flip across this axis, then I basically leave x alone and I subtract y from 5, and that gives me a flip. And the most difficult one to visualize is actually the easiest one to implement. We're going to transpose, which means we're going to flip the x and y axis. So if you've got 2, 1, it's going to become 1, 2. 2, 2 is going to become the same, and 3, 2 is going to come the same. So the end result is that it flips across the diagonal line that goes from 1, 1 to 4, 4. So if you have a shape that looks like this, it'll basically be the same shape laying on its side like this. So there's transpose, and you take a look at that 2, 1, that becomes 1, 2. So all we're doing is changing the x and y. And once again, take a look at that 2, 3, and that becomes a 3, 2. So all we're doing is flipping the x and y. Why are we doing all of these simple geometric functional transformations? Well, because it makes it easier to rotate the points. Here's what I mean. So if we start with this shape, we start with a set of points. To rotate it 0 degrees, all we need to do is leave all those points alone. Then it gets a little bit more complicated, but not very much. It turns out that you can rotate any increment of 90 degrees using only flips and mirrors and transposes. So, for example, if I want to rotate 90 degrees, I start with the points, and then I flip it across that x-axis, and then I transpose. So you can see we've rotated the shape 90 degrees. One more time. I do a flip and a transpose, and bam, we've rotated 90. 180 is pretty similar. We do a flip and a mirror, right? So here's the mirror, and here's the flip. So we start with the L, mirror, flip, and there it's rotated 180 degrees. What about 270? Well, we start with a mirror, and then we do a transpose. And there we are. So using these techniques, it's going to be very easy for us to layer some techniques. So first, all we're going to do is manage these flips and mirrors for a single point on a 4x4 canvas. And we don't really care about anything beyond a 4x4 canvas because we can basically do all of our rotation in the upper right-hand corner. And then once the rotation is done, we can move the points using our move function to wherever we want it to be. And that's how we're going to proceed. Okay, so in the code base, we are on checkpoint 4 if you're following along. We're at the GitHub or the Quad Block 2 branch, and you can check out checkpoint 4 and be in sync with this particular exercise. So I'm going to add them to edit the code base. And we're going to spend most of our time, or pretty much all of our time, on the back end. And we're going to implement a couple of different features. So we've got add shape and move, and since these are moving, all of these earlier functions are just moving things around, let's implement our features in this way. So we're going to do a def transpose, and we've got an x, y. So this is going to basically return y, x. All we've done is flipped it across that diagonal axis, but the implementation is just changing x and y. So I'm going to mirror, and remember, this is basically moving across that that vertical axis. So that means that my y points are going to stay the same. We're not going to change y at all. We're basically going to change the x coordinate. So this is going to be return 5 minus x. So if it was 1, I'd return a 4. If it was 4, I'd return a 1. If it was 3, I'd return a 2, and so on and so forth. So that's what mirror looks like, and flip is very similar. Flip x and y is going to be x, but 5 minus y. And that's all I need to implement some pretty sophisticated rotations. And I'm going to go ahead and do those in points. So I'm going to say def rotate, and this is points. And if I'm rotating 0 degrees, all I need to do is return points. So to rotate 90 degrees, I'm going to do a points, flip, and transpose. So let's do that. So I'm going to rotate points and then 90. I'm basically going to do a pattern match here. There are other ways to do this, and I encourage you to find them all, but I'm going to do a point, and I'm going to do an enum dot map, and I'm going to take a function with a point, right? And I could take the point. You know what? I could probably one line this and it would probably look okay. Let's try it and see. Point. And then I could do a flip. I think I like that okay. Let's see if it looks better as a, if we break this function down like that. Point. Yeah, maybe this is a little bit better. Okay, so all we're doing is we're mapping over. You know what? I'm going to actually do these rotations. It will work the same if I put them on point. And this is actually a reducer on point. And this will simplify this. Point degrees. And then all I'll have to do is, I'm going to grab, well, I don't need to grab that code. This can go away. So all I'm going to do is take the, I'm going to say point.rotate, and then, or actually I'm going to say enum.map points, and then I'm going to take a function with a point, and I'm going to say point.rotate, and then point degrees. I think I like that just fine. And since this is a little bit complicated, I'm going to pipe this in just so we're doing a little bit of mental work at a time. Yeah, I think that that is just fine. So I'm piping points into enum.map, and basically that map is going to take every point and it's going to rotate it to the specified number of degrees. So that means that I'm going to do my rotation here, doesn't it? So def rotate, so point 0. Let's not one line that. And then we'll create a few of these. And so if that's 90, it'll look like this point, and then a flip, and then a transpose like that. And then I can basically take this and copy it. So that was a flip and a transpose. So what is 180? Let's take a look and see. 180, I take the points, pipe that to mirror, and pipe that much to flip. So that's what we'll do. That's beautiful. And so this one, instead of a flip, that's going to be a mirror. So this is what the effect looks like. I'm doing a points, mirror, and then transpose. So that's got me going. That's got all the different rotations specified. So here we go. That's the mirror and the transpose. So that ought to get these things moving. And so I'd like to be able to see the work that we're doing in the context of the live view. So let's go ahead and get that started. Here's my server, and you can see that it's just dropping these shapes one after another. Now, eventually we're going to wire up the individual rotation to a key. But I guess it would be just as interesting whereas as we're processing the down, we could just rotate this another 90 degrees. So let's look at the code base and see where that's going to happen. So if I go into my live view, let's track through what's happening. So I'm in game live, and I've assigned the new tetramino. Let's look at what that does. So the new tetramino puts the tetramino in the socket. That's just a new random one. And the show grabs all my points. So let's see what happens when I get a clock tick. So I do a socket and a down and a show. So maybe I can add a rotate there. And so the rotate is going to look a lot like this, isn't it? So the down. Oh, I do the show here. I do the show twice, don't I? It doesn't need to have a show here, does it? Yeah, we don't need to do that show twice. So, yeah, so I'm going to take this, I'm going to establish within the rotate. Now I'm lost. Okay. Yeah, so I'm going to turn the rotate on there. And we don't need this extra show here, right? Okay, so, and we were going to add a rotate here. So, and we were going to make that look like down. That's where we were. Okay, so let's call this a rotate. So rather than location, let's see how we implemented that rotate. I think that all we really need is the tetramino, if I'm right. Right, so I have the tetramino, And I don't need a new tetromino in this case. What I need is, I'm going to say so with the implementation of down, I was calling tetromino down, so I'm just going to call rotate. Let's see if I'm right. So in the tetromino, we have the rotate. Yeah. So basically, this is going to go to the next rotation, right? So if it's 270 degrees, it'll flip around to 0. Otherwise, it'll just add 90. So that's exactly what we want. So I'm going from 0 to 90 to 180 to 270, and we're off to the races. So let's see what that looks like. Okay, so I'm crashing here pretty spectacularly, I might add. So let's see what's actually happening. So rotate to is undefined or private. So let's see exactly what's happening here. So rotate. So I'm in game live. Tetromino. Oh yeah. So I'm taking the tetromino and I'm taking the socket and I'm passing it to rotate. And that's not what I want to do here. Basically, I want to take the socket and I want to assign a socket. I just want to assign the socket, the tetro to the wow, that was a mess, wasn't it? Okay, so all we're doing here is this is a reducer over socket. So it takes a socket right here, and we pattern match to pluck out that tetromino, and assign is going to return a new socket, but one with a tetromino that's been rotated a little bit here. So let's see if this is looking better. So it's not actually rotating around for me, which is a little bit disturbing here. So I'm actually doing the down, rotate, and then show. So the rotate is moving the tetromino around. So we can actually see, we ought to be able to see if our rotation is changing. Yeah, so the rotation is changing exactly as it should. So the question is, where are we getting? So, oh, I know what's happening. Yeah, so basically we're getting the new rotation. We're just not reacting. We're not rotating the tetromino as part of our show. So that's the last part that we need to do. So let's go into tetromino and let's see what's happening with this show. So the show is right here. So we take the points and we move the points and then we add the shape so that they can pluck out the color. But what we don't do here is points.rotate. Right. So we basically start with a tetromino and then get all the points for it. And remember, the points come from these individual shapes. And so once we have the points, we can move them. Oh, you know what? The rotation has to come first, right? Because we need to move this on that 4x4 canvas, or the quick math trick that we use isn't going to work. So we basically take the points and then we rotate them and then we move all the rotated points to the right place. And let's see if this is looking more interesting now. Oh, it's moving around spectacularly, isn't it? Oh, I didn't save. That's the whole problem there. And let's save this guy as well. Okay, so there we go. Look at the spinning on the way down now. It's rotating all the way down, and now we should get a new one, and it should start rotating. You can't tell. Yes, you can. We're rotating, right? There it goes. And here's the next shape. And it's rotating, that T shape is rotating around. So you can see it wobble a little bit. That's okay. Basically, it's hard to make things exactly centered in this game because some of these pieces are 3 wide. And so if we showed that on a 4x4 canvas, it's going to wobble a little bit as it falls. And you can see the same thing that's happening as we rotate the stick, the I shape as it falls. But that's a pretty good place to wind up. So we've basically, through a couple of tricks in geometry, we've implemented the rotation. And eventually, we're going to tie that rotation to an individual key, maybe the key down, and we'll tie the move left and right to the right and left keys. And that'll have pretty much most of the game mechanics in terms of user input set up pretty well. And what we'll need to do is put some guardrails on. So probably the next thing that we should do is implement our keystrokes, and that will be next. So let's review what we've done so far. So in this session, we used the ideas of math, and we implemented a couple of really basic features: mirror, and we implemented flip, and we implemented transpose. And then we built reducers around those so that we could take those reducers and implement a rotate 0. Well, the rotate 0 was easy. We just returned the points. But the 90, we just applied a couple of reducers to the same group of points. The same thing for 180. We just applied the flip, the mirror, and the flip reducers, right? And then for rotating 270, we applied the mirror. So we had the very tiny functions for transpose, mirror, and flip. Then we could apply those reducers, those simple reducers, to basically lay out a script. And you can see this very much follows the shape of constructor, or basically a chunk of data, and then reducer. And then later on, we applied the same reducer to points. And then we used that reducer to our tetromino, and we tacked that into show, right? So we added the rotation in here. And then we basically added the same reducer into what happens when the clock ticks. So now, when the clock ticks, I basically take the socket, I move down, and I rotate, and I pipe that to show. So this is a great little description of how different reducers are used in different places to manage a task. So this is Bruce for Groxio Learning with the dog on the floor, and we'll see you next time.